Thank you very much for being patient with me. Welcome to this afternoon session. I hope that you found that what you've seen so far has been useful, and particularly if you've seen any of the taster talks and also had a look around the department and maybe even some of the colleges as well. So let me introduce myself. My name is Steve Morris. I'm a Professor of Engineering Science here in the department at the University of Oxford. I'm also a tutorial fellow at Jesus College. So like many of my colleagues, we have both a college appointment and also a department appointment. I'm actually here in my capacity as the Associate Head for Teaching, where I will be giving, hopefully over the next 35 minutes, I hope not to keep you any longer than that, just a bit of an overview of our course, a little bit about the admissions process and some other general information which hopefully you will take away and find useful. So, welcome to Oxford. If you don't know Oxford at all, the population of the city is around about 150,000, 160,000, depending upon where you take the outer limits. We have two universities here, ourselves the University of Oxford and Oxford Brookes. There is a mixture of high-tech industry in and around the city, located at different science parks and within the city limits. You may know that the Mini is made here at our site. And at any given one time, the university has around about 20,000 students. And they are spread across undergraduate and postgraduate courses, across the 39 different colleges and all of the departments that make up the 4 divisions. So the university is split into 4 divisions: the medical sciences division, humanities, social sciences, and the mathematical and physical life sciences, the MPLS. And we are a department within that MPLS division. So this is a bit of a bird's eye view of the city. So we are, where this top red arrow is, we are here at what we call the Keble Road Triangle. This is where the Department of Engineering is. Actually, engineering is split over a number of sites. I'll say a little bit about that at the moment. But for the most part, the students will come here for their lectures and practical elements. So you can see, so the city centre is just down here, so it's only a short walk away. You can see all of the different colleges that make up the universities, all within easy walking distance. None of the colleges are more than 25-minute, 30-minute walk from where we are. You can also see, in addition, the University Parks, which is just to the right of us, which is, if you need a bit of a respite from this department, you can get out and enjoy a bit of sunshine and walk around the parks. So, as I said, the department is split across 5 different sites, but pretty much all of the undergraduate teaching in respect of lectures and labs takes place here. So this is the Holder and Tom buildings. Next door to us are the Jenkin building, the original building of the Department of Engineering Science, a more modern building, our Information Engineering building, and our Engineering and Technology building. So this is one of the tallest buildings in the city. If you go to the top, you may have already been up to the 8th floor, where we have some of the lecture theatres as well as some of the study spaces. You have one of the best panoramic views of the city overlooking the Radcliffe camera and some of the colleges. It's actually one of the few places you can stand in the city and not have to look at the scaffolding and this rather ugly building as well. So it's a good viewpoint from at the top there. We also have sites at our Institute of Biomedical Engineering as well. So this is actually up on the hill next to the John Radcliffe Hospital. And that's because our biomedical engineers work very closely with the clinicians and the medical teams, where the technology is being developed for specific applications that can go into deployment. We also have laboratories at Oseley site. So this is at Southwell. Our Oxford Thermofluids Institute is based there. We also have some chemical engineering going on at the Begbrook Science Park, just slightly north of the city. And in principle, over the duration of the student's undergraduate degree, they could actually access any of these facilities. But for the most part, certainly for the first couple of years, they'll be largely concentrated at this site. So our ethos is really that engineering in the modern world is very multidisciplinary. Whilst there are many different branches of engineering, our view is that actually to be an engineer today, whether you have more of a specialism in electrical, mechanical, information, actually having a grounding in all of these different areas of engineering is of real importance, particularly if you're going to take on leadership roles where you need an appreciation and an understanding of these different fields. So this is just one example. You take a tidal turbine. when you really break it down, you realize actually how many different branches of engineering feed into this. There is, of course, the environmental impact and environmental engineering that needs to be considered. There's the structural aspects of something as large as this. There is, of course, because you've got moving turbines, the mechanical side. There's the extraction of the energy in the form of electrical energy. So the electrical engineering that needs to go into this. You might have information engineering in the form of machine learning or AI that's helping to control the running of this. There is, of course, if it's embedded in the sea, then you've got the fluid mechanics aspect. It's a civil engineering task. And of course, with these blades moving, it's a turbo machinery problem. So you can see just with one example here that actually to make something like this work, you need inputs from all of these different areas. And whilst you might have specialists in each of those areas, we were trying to give our students the grounding that they would have an appreciation of all of this and can have engaging communication with each of these specialist fields. So we're very much a unified general engineering department. And yes, please do.
The information engineering, is that the same as computer science? Or?
It's effectively applied computer science. I'm sure if you talk to my information engineers, they would say, no, it's not computer science. So the Oxford robotics, for example, when the robots outside is mode, that comes under information engineering as well. And that perhaps wouldn't be covered in a purely sort of a more general computer science thing. So there are aspects that are slightly different, but it does encompass things that you would see in computer science. Okay. So it is very much an interdisciplinary foundation. There's a real focus on teaching the students how to solve difficult and challenging problems in engineering. We are a research-intensive institution as well and department, so we are able to leverage that research and feed that into our teaching as well. We have a number of spin-outs from the department and spin-out companies. Some of these actually have been led by students themselves. As an institution, we are the leaders in the UK in terms of spin-outs from a university. Using our research side, we're also able to provide our students with undergraduate research opportunities. So during the summers of their second and third year, they can actually apply to stay here for another 8 or 10 weeks and actually get embedded into a lab and do research. We really try to, through this foundational learning, teach them to be leaders in the industry. And we're very fortunate that our graduates are highly sought after. So in general, we have more than 95% go straight into either some form of employment or further study. And the average starting salary for our engineers is typically somewhere between 10 and 14% higher than the national average of those coming out with engineering degrees. So these are all the branches of engineering that we cover here at Oxford, ranging from biomedical engineering all the way through to information engineering and thermofluids. And so what I wanted to just do is give you some examples. I can't give you an exhaustive list because it would be far too long, but just give you some examples of our sort of connection in terms of outputs in engineering and where we're sort of connected to the real world. So an obvious one is our engagement with Rolls-Royce. We have been working with them for many decades. We have people here that are actually employers of Rolls-Royce that actually teach on our course and work down at our research labs. This comes in different areas, so in terms of aircraft engine, turbo machinery, solid mechanics, material development. And so we have a long-standing relationship working with Rolls-Royce, and the students can get direct access through that, not just in the courses that they take, but if they do in their final year projects, they may actually be working on solutions to problems that are being considered and are challenges for companies such as Rolls-Royce themselves. Through our research, one of our flagships is the Oxford Robotics Institute, and something that we have here is autonomous vehicles. So there's a lot of development. This was a spin out as well. It was originally called Oxbotica, now called Oxa. And students actually, if they do their final year project, might actually get to work on the machine learning, the algorithms that are involved in the development of this, not just in that, but also the hardware as well. I do know of some students who chose these as projects, and the first thing they were given was, rather than a computer to do the coding, they were given a crash helmet and told to sit in the driver's seat while somebody else drove the car from a completely different building, which I don't think some of the students realised what they were signing up to. But they did get to play with the hardware later and do some of the algorithms. Another area is on the biomedical side. So we have a number of spin-outs from here, but also a number of technologies that are actually feeding directly into the hospital and to clinical settings. So one of which is oxonics. So this is using ultrasound technology to effectively improve drug delivery for tumor targeting and also cancer treatment. And so this is a spin-out from the university. This also has projects which are related where students can get directly involved in this. These are just a snapshot. There are many different examples I could give, but I don't really have the time to go into great detail on all this. But you can sort of see across all the different branches of engineering, we have different opportunities for the students. So our teaching approach really comes in 3 different modes, 2 of which are traditional, so the lectures and the laboratories. So these are your lectures, so the first 2 years of the cohort, so that's from all of the colleges, will come here and they'll sit in the room where you are and have their lectures on all of the foundational topics that we cover with them. And then they'll have practical elements that accommodate that. In addition, we have the tutorials, and this is obviously something that's perhaps more unique to Oxford and Cambridge. And this is where they will have, within their colleges, certainly in the first 2 years, in the latter 2 years that will be more likely in the department, this is where they have direct access to the academics. And rather than like the lectures, which is a one-way communication, although there's still some engagement in that, the tutorials are very much a 2-way communication opportunity. So it's an opportunity for the students to really go into detail in the problems that they're working on with their academics. They can go through and to discuss the course and really sort of get into under the hood of what's going on their particular area that they're focused on in their lectures at the moment. The college tutors can provide career and skills and advice as well. So that advice might be through their connections in industry and can provide them not just with advice, but opportunities as well. And then also the skills to what they need to do to become engineers. We also have the examinations. That's, of course, what they have to do to get their degrees. The examinations are actually controlled and maintained by the university, so that's actually done at exam schools. So we actually have in Oxford a dedicated building where the students actually have to get dressed in what's called sub-fusk, so a rather formal attire, where they then wear a carnation of the right colour, depending on their year group, to go in to have their examination. So there's a bit of a minefield for the students before they've even got in and sat and done the paper to make sure they turn up with the right attire. They can actually be turned away if they turn up with the wrong attire. So there's quite a challenge for them. In addition to that, we also, of course, provide the space, ideally, to support their independent learning. That's in the form of libraries, but also in study spaces. So you might have seen the study spaces here, but pretty much most colleges have study spaces. Something that's become very popular in recent years is the students do like to work at cafes as well with their laptops. That does happen. And then, of course, we provide lab facilities for the practical elements. So in terms of the department and college, how do they interface with one another? So our department is where they have the lectures, so they'll come here, as I say. Now, in the first couple of years, they'll be in cohorts with, so lecture sizes between 170 and 180. So that's our cohort size. As they start to specialize, so years 3 and 4, that might even reduce to, so in their 4th year, they might be taking such a specialized topic, then there might be only 6 or 7 people in that lecture with them. Their laboratories also vary a little bit in size depending on the year group. So in the first couple of years, they will be split up with the cohort. So they won't just be with their own college, they will be with maybe 2 other colleges in their practical elements. And then that reduces in size as they start to do more specialized topics. In the 3rd year, they did a design project where they have to work in teams. And those team sizes are usually somewhere between 4 and 6 students. And then in their final year, they work on a research project, and it's just them that's working on that particular project with an academic supervisor. With regards to the college, so this is where they have the tutorials, typically, and this is certainly true in the first couple of years where it's a bit more regimented in terms of the timetable, they will take usually between 2 and 3 1-hour tutorials. They might be a little bit longer than that, so maybe an hour and a half. This is in these small groups of 2 to 3 students, usually no more than 3 students. And our model in engineering is that for every 4 lectures that the student attends on a particular topic, they are given a problem sheet. And that problem sheet usually has somewhere between 8 and 10 problems on, engineering problems related with that particular topic. And they have to then go away and do that in their own study time. And then that's what they will discuss and go through in their tutorials. It's not necessarily confined just to those tutorial sheets. They can do anything around that course as well. But the tutorials give it a focus, the problem sheet gives the tutorials a focus to begin with. In terms of balance of workload and study time, this is a bit of an estimate, but it varies a little bit throughout the course. And from the department side, you're looking at the students are doing somewhere between 6 and 10 lectures, so 6 and 10 hours of lectures a week. Usually in the first 2 years, that's confined to the mornings. Each week they will have laboratories that are somewhere between 5 and 7 hours. And then in the college, they would have 2 to 3 hours a week of these tutorials. And then on top, and then sort of the rest of the time is sort of for private study, so somewhere between 10 and 20 hours. And we tend to keep Wednesday afternoons, as if we can, it's not always possible, to be free so that they can engage in other extracurricular activities. So the university and the colleges are very rich in what they can offer in terms of extracurricular activities, whether that be music, whether that be sport, whether that be the theatre, whether that be other societies. And so we do try and give the time to allow them to engage in those as well. But it's very important, the timetable is for them to manage. And whilst there is support for that, certainly within the colleges, it's up to them to manage their time and allocate sufficient time for the personal study. So our course is split into two, really, in the respect that in the first 2 years, it's core. And what we mean by core is that all students take the same topics. So they have no choice at all, unfortunately, in that they have to do all of these, what we consider to be foundational courses. So there are 4 examination papers in year 1, and each one of those examination papers, so this is maths, electrical engineering, materials mechanics, and energy. And each one of those is associated with a lab element, and I'll say a little bit more about that. At the end of that first year, they do what we call preliminary examinations, and those examinations are really a qualifier to make sure that they can continue on to the final honours scheme. What they get here, as long as they pass, does not contribute towards their final degree classification. When they get to the second year, again, it's very much core material, so they have really no choice. So they have 4 examination papers in a similar way. Maths is also another one of those themes there. And again, lab work that complements that. The only bit of choice they get is these coursework modules. So these are week-long practical elements that span the different branches of engineering, and they choose 3 of those. But one of those has to be in computer-aided design. At that point, they then have to sit their first of the finals. And what they get here also does contribute towards their final degree classification. Once upon a time, it was very different. All of the exams came all of the finals came right at the end of the course, which was quite brutal for the students. At least now it's spread out a bit more. In years 3 and 4 is when it starts to specialise a bit more. So now there are some core elements like the engineering computation project, the engineering and society, and the design project. But within each of those, there's some degree of choice. But where they do get a lot more choice is in the options. So we have 16 different option papers. Each one of those covers a different branch of engineering. And they can take whatever combination, whatever 5 papers they want to. And they don't have to even silo themselves at this stage. So if they want to do a little bit of electrical, a little bit of biomedical, a little bit of control, they can do. They don't have to go down one particular theme. And with each of those papers, there's an associated lab class. The final year is where they have a lot more choice in that they choose a research project which runs throughout the whole year, and they do that with an academic supervisor. This has to be an original piece of work. And then out of 30 different papers, they choose 6 option papers. And again, they don't have to go down a particular pathway. They can spread across all of them. We make sure that these are timetabled so that there's no clash between courses. So if you want to do a bit of civil engineering and a bit of biomedical, you can. There's nothing stopping you doing so. We do have a slightly different pathway that they can undergo, and that's called the EEM pathway. This is the Engineering Entrepreneurship and Management pathway, or EEM pathway. Now, the students don't have to choose this from the word go. They make this decision at the end of year 2. And really what differs here is that now they do some of their courses at the business school, at the side business school. So they do some courses in management as well. So they have a slightly different set of papers where they go into more detail on the management finance, entrepreneurship side. And the students can go down that pathway as well. It's slightly competitive, so we have a limited number of places for this, so they have to apply at the end of their second year. Their fourth year is also ever so slightly different in that they, rather than doing a research project with an academic supervisor here, they could do a 24-week placement in industry, which they can help set up. In terms of the practical elements, there are effectively practical parts in each of the year groups. So in our first year, we have what we call our DBT model, which is design, build and test. And these come in the areas of computing, electrical and mechanical. We have drawing and design labs that they learn in the first year. And then other labs such as the workshop in practice. We have a 3D printing lab. We have a thermodynamics lab. In the second year, the labs dovetail with the courses that they're learning. So this is when we introduce them to communications, control, instrumentation. And so they see practical elements of that to complement the theory that they're doing in the lectures and the tutorials. And then they choose one of these coursework modules. As I said, there's 4 different computer-aided design coursework modules. They choose one of those, and then they choose any other 2 of their choice. Sometimes one of them that is quite popular is the chemical engineering one, which involves setting up their own brewery, little microbrewery. So, I have to say the beer is pretty unpalatable that they produce, but they enjoy it and it's good fun for them. In year 3, they have an engineering computation project, and they do this design project, which I mentioned, and then there's a lab with each of the option papers, and then they have their 4th year project, which may or may not be completely hands-on. So they could do an information engineering one, which is, of course, more about the coding and the algorithms, but it could be very much a hands-on mechanical system. So I mentioned about the laboratories. So in terms of year 1, we have this model of a design, build and test. So once upon a time, it actually used to be an AM radio. So they would design that, they would build it, they actually have to do the soldering, they have to design the station that they tune into. Sadly, with the AM mast being removed and switched off, there was very little choice in what they could actually tune into. So we've moved over to a music box, which they now build. We have the model bridge, so the mechanical one, they design and build a bridge, and then they test that bridge. And it's quite competitive. The students are competitive with each other, which bridge can support the biggest weight. I'm sure sometimes behind the scenes there's a bit of sabotaging going on across the bridges, so that they can compete with each other. But that's all good fun, and they learn how to do that whole process. And there's a similar one with the computing. In year 2, they get to play with some of our more expensive tools, so our drones, our robotic systems, our electrical induction machines, our DC motors, and they can play with that, and they see those hands-on. So they can actually take what they're learning in the theory, in the lectures and their tutorials, and applying that into actual practical systems. Year 3, I mentioned the design project. So this is purely paper-based, so there's no actual practical element to this, but this is where they have to design. They're given a brief. Sometimes these briefs are quite broad, and they have to come up with a design. One of the projects that's been very popular in recent years is the design of a detector for the Large Hadron Collider for CERN. And then after that, at the end of the project, so again, this runs for the majority of the academic year, the students get to present their design for a detector to the people at CERN who work on the detectors. So that's a nice experience. There's some other examples here. We usually have 13 to 14 on offer each year that the students can take from. The design of the electric and hybrid Formula race cars has also been another one that's been very popular. In terms of the final year project, we usually have somewhere between 200 and 300 projects on offer for a cohort of 180, and the students can take. So this is very much, it has to be an original piece of work. It's a very big part of their component of their degree. This is very hands-on, and they really lead this. Now, for the most part, these are projects that have been devised by the academics themselves, but we also have it that the students can devise their own projects. So by the time they get to their 4th year, they're pretty experienced and they have their own ideas of what they want to look at and what they're interested in, what they want to specialize in. And so they can come up with their own projects and approach an academic supervisor and say, I'd like to do something on this. Would you support me? And more often than not, we're able to accommodate that. We do have an exchange scheme with Princeton University. So after the 3rd year, the students can actually apply to have their final year at Princeton, and we have a few Princeton students come the other way. How many we send across from Oxford depends a little bit on how things come across from Princeton, how many students come across. It's usually a relatively small number. If the students do this and do their final year at Princeton University, they still come out with their Masters in Engineering degree at Oxford, even though their final year wasn't here. It was at Princeton. We have an agreement with Princeton University. We have a number of student societies. You may have seen this when you came in on the ground floor. One of our most popular student-led societies is our Formula student team, the Oxford University Racing. This is very impressive, I have to say. The students really do lead this. We do have an academic involved that supports them, but it's very much driven by the students in many different ways, as well as driving the car. And they really go back to the design and build of this. And actually, this is quite a nice pathway as well to employment afterwards. We've had a number of people who've worked on this as their additional extracurricular activity, who've then secured positions with Formula One teams following this immediately. So it's been a nice career path for them. And they're very passionate about it. I mean, they're here till very late working on these things. We have a number of other student-led societies as well, which I list here. A more recent one that's been added is an aerospace and rocketry society. And so this is very similar, not quite yet at the level of the Formula student, but again, they're building their own rocket and they're competing with that with other universities. So where do our students go after graduating from Oxford? Well, around about 40% pleasingly stay within the engineering-related field and engineering-related employment, so they use those skills that we teach them here. But others, some go into IT and computing, so they do get a lot of experience from that side that they can then take their ability and apply that into that field. Consultancy, which can include in engineering consultancy as well. Their ability to problem solve and deal with big challenges sets them up well for that. In the finance district, we do have a reasonable percentage go into that because we're quite a mathematically based course. And with the algorithms and the information engineering they're taught as well, that also sets them up well for that. Around about 20% go on to further studies, so that can be in the form of either a second master's degree, but more often than not, it's a PhD or DPhil, as we call it at Oxford. And then a sort of small percentage decide that engineering really isn't for them and they do something else. So the colleges, and this is something that we often get asked, is how do you choose the college? And I say that's a very difficult answer to give. These are really they're a very supportive community, and it's down to the individual about what's important to them for the college. There are 39 colleges at the university, but not all of them offer engineering, so it's really important to stress that. There are 27, these are the ones that offer engineering. So most of them they're all undergraduate colleges, so they take undergraduates as well as postgraduates. There's a mixture of the old and the new here, the large and the small, some with different interests in sports, some are more musically oriented. It's very much a question of going in and seeing this is your home, this is the student's home for 4 years and beyond. Once you're a member of a college, you're a member of college for life. And we have people coming back over many decades, catching up with old friends, but it's a base for them forever, really. And so I do advise seeing some of the colleges, but identifying what it is that's important for them when choosing a college. They don't have to choose a college. They can put an open application in, okay, and we assign a college. All of the colleges have at least usually two or three tutors across the different branches of engineering. And sometimes if a tutor in a particular subject, let's say civil, isn't at your college, there's a good chance you'll have interaction with them anyway, even though you're not at their same college. Have people had a look at colleges already, had a look around? Yeah. So the application process. So if you haven't done already, please can I advise that you have a look at our website. There's a lot of information on the application process. There's a lot on the university website as well about the application. So in terms of what we do in our selection mechanism is, there's the written test, and that's the PAT, and it's exclusively the PAT. So we don't take the ESAT, it has to be the PAT. And then there's the UCAS form, and on the UCAS form, the three indicators for us are the personal statement, the reference, and their predicted grades, as well as their previous exam results, and that's all contextualized. Our standard offer is 2 A stars and A levels, and if it's IB, it's 776 with a minimum of 40. We do take a range of international qualifications as well, but they're described in more detail on the university's website. There are some international qualifications that we don't take. So really, these metrics are what we use, these indicators are what we use for our shortlisting for interview. And then each student or each candidate comes in and has 2 interviews, one at each college. That first college might be the college they've chosen, and then the second one is a randomly assigned college. If they've done an open application, then it'll be just 2 randomly assigned colleges. Okay. The aptitude test. So we cannot consider the application unless the aptitude test has been taken. Please be aware of the date. It's really important. So registration for the PAT is now open, closes in late September. Once you have registered, you are then given access to the portal where you can then book in at which test centre the test will be taken and also the date. Now, if you look on the university's website, it talks about admissions test for Oxford running over a certain week. That's true in the respect that all subjects are happening that week, but the PAT is only happening on the Wednesday and Thursday of that particular week, so please bear that in mind. I don't know the portal so well myself, but I understand that perhaps if you do leave it very late, in terms of certainly registering and then booking your place, you may find that some test centres aren't able to accommodate you. Okay, so just bear that in mind. So what we look at interview is seeing how the student... Oh, sorry, yes?
The test centres are in the UK and outside as well?
I believe so, yes. I couldn't tell you exactly all of the locations, but yeah, and that information is available online. So you can find out where they are before you do the registering, I believe. Yeah. Okay, so in terms of the interviews, what we're looking at both sets of interviews is the ability to basically take their knowledge that they have acquired so far in maths and physics in particular and apply that to problems that they won't have seen. And it's really about how they approach those problems, how they break it down, how they structure it logically, how they work through these problems. It might be that we also give them something new, what we know they won't have seen, and then how quickly they can adapt that and apply that to a problem. And of course, we don't sit there in silence. We talk to them and we engage with them and we help them through. So we're looking for how quickly they can pick these things up and what's their reasoning. Is it clear reasoning or is it quite muddled? Last, and certainly by no means least, what's their interest in engineering? Why are they enthusiastic about studying engineering? So giving some thought to that is really important. And I really stress as well is that, that this can come across in the personal statement, but also in the interview. This should be genuine. It's about their interest. They shouldn't be telling us what they think we want to hear. They can also come unstuck that way as well. So it's really important that they've thought about what is it that they want to do engineering. And is it because they're doing engineering because they like maths and they like physics, but they don't want to do either of those at university? Well, yes, that's a very honest answer, but have they given it more thought than that? I want to start wrapping up. Of course, it is expensive going to university. The university does what it can to draw on resources to make available quite a large number of scholarships. It commits something just over 10 million towards scholarships. These scholarships are non-refundable. You don't have to repay these back, unlike the loans. So if this is of interest, please do have a look. There's a lot of extensive information on the university website where you can see what scholarships are on offer and what these provide and what the eligibility requirements are. So in terms of fees and funding, as you may know, the college and university fees for home students are fixed by the government at £9,500. But the overseas figures are, let's say, more substantial. There are student loans, of course, for the UK students. These are fees loans to help with the tutorial fees. Then there's also, depending on the household income, maintenance loan, and those maintenance loans are repayable on graduation. And if you are eligible for it, one of the Oxford bursaries, and they are not necessarily repayable. Sadly, when the department first opened in the early 20th century, I think it was something like £1 a term to attend. And sadly, we haven't been able to stick to those costs over time. But this is where we are at the moment.
What is the composition of UK students versus international?
It varies year on year. The majority are home students, of course, but it varies. It does vary and fluctuates. You're usually looking at. It depends a little bit. In fact, if you look on the website, you can see how those statistics have varied over the last few years, both in engineering, but as a university as a whole. But typically, 60-70% are home students, if not more. So in terms of something that's of course front and center generally for all of us at the moment has been mental health. And in terms of the support for that, the university does have a number of mechanisms in place, both at the centre. So centrally, the university has welfare support and well-being support, but also this is where the colleges do add something quite significant, is that each college typically has its own welfare support and support team. And we have different mechanisms for picking that up and providing that support, whether that just be helping with preparing for study to more serious situations which need support from the college and the university. So I don't want to keep you any longer. I want to finish there. If you are interested, the university has just released its undergraduate admission statistics for the last few years. So there's a lot of detail on there, breakdowns in terms of home against overseas, by gender, by background, and so on. So please, if you're interested, to have a look. This just really leads me to welcome you to Oxford. I hope you find today useful. I will stay around for a few minutes if you've got some direct questions, and please feel free to ask any of the team that's working around. Thank you all.